Θέλω να σας καλωσορίσω όλους σε άλλο ένα Meetup της ελληνικής κοινότητας. Σήμερα θα ασχοληθούμε, πέρα από ό,τι συνήθως ασχολούμαστε με το bitcoin, θα ασχοληθούμε με ένα άλλο κρυπτονόμισμα, το οποίο έχει πολύ ιδιαίτερο ενδιαφέρον, όπως θα μας εξηγήσουν οι ίδιοι ομιλητές. Δυστυχώς μου πέσει πίσω στο πρόγραμμα, οπότε θα σας κάνω μια γρήγορη ερώτηση. Αν υπάρχει κάποιος εδώ που δεν έχει καμία επαφή με το αντικείμενο και είναι η πρώτη φορά που ακούει για το bitcoin και το blockchain και όλα τα cryptocurrencies γενικά. Πάρα πολύ ωραία. Βλέπω όλοι κάποια βασικά πράγματα θα ξέρω, γιατί θα κινηθούμε λίγο πιο ταχύρυθμα για να μπορέσουμε να μιλήσουμε για το Monero, που είναι το κύριο αντικείμενο της συζήτησής μας σήμερα. Ό,τι ερωτήσεις έχετε περί των εισαγωγικών θεμάτων για το πώς δουλεύει το bitcoin, για τα πορτοφόλια, για το πώς γίνονται συναλλαγές και για το πώς μπορείτε να εμπλακείτε με αυτό περισσότερο, θα το συζητήσουμε προς το τέλος του Meetup, που ο φίλος του Δημήτρης θα σας δώσει μικροποσά σε bitcoin για να φτιάξετε πορτοφόλια τοπικά και να μπορέσετε να δείτε και μεταξύ μας πώς δουλεύουν οι συναλλαγές, αν θέλετε να το δούμε μαζί. Και ας συγκεντρώσουμε τον περισσότερο από των ερωτήσεών μας σχετικά με αυτά που θα μας πει ο Justin, ο Riccardo και ο Ronen λίγο πιο μετά. Οπότε, without further ado, let's start with our first presentation. Όλες οι παρουσιάσεις θα είναι στα αγγλικά. Αν υπάρχει κάποιος που έχει θέμα με αυτό να μας το πει για να προσπαθήσουμε να μεταφέρουμε όσο περισσότερο μπορούμε στα ελληνικά εκεί πέρα. Alright, so we're going to do this in English from now on. Justin, please step up and let's start discussing Monero.
Hello, everybody. My name is Justin. Thank you so much for coming out today and learning about Monero, which I spend a lot of time learning about this cryptocurrency myself. It is a secure, private, and untraceable currency, and we have a great lineup for you today. Right after I speak, we have the actual core maintainer of the project, Riccardo Spagni, who is speaking. And so, obviously, I hope you all enjoy that. But first, there's me, so I'll introduce myself. My name is Justin Ehrenhofer. I'm a second-year university student studying finance and management information systems at the University of Minnesota. At Minnesota, I also am the president of my school's student cryptocurrency club there. Today, we just hit 100 members, so we're really proud of that. And I'm currently on a semester exchange program at the Dean University of Economics and Business. That makes it a lot easier for me to come to Athens and speak to you all instead of coming directly from the United States. On Reddit, you may see my username as Samsung Galaxy Player or elsewhere as SGP. I'm not paid by Samsung, it was just that I needed a Reddit username and I just chose the name of the tablet I was using Reddit on at the time. So it was more so out of laziness than anything that I had that username. So without any further ado, I'm just going to jump into the technicals of Monero and the reasons why that Monero is as private as we say it is. So it really is private in these four ways. And I know we didn't have much time to talk about the way Bitcoin works today. I know I will take a lot of liberties, so I apologize for that. But there's really four ways that Monero protects the privacy. So just to give a quick overview of how transactions normally work, Monero works in many ways similar to Bitcoin. You have the sender and receiver in the transaction, as you see there. You have the transaction broadcast, so when you want to make a transaction, you need to tell the rest of the either Bitcoin or Monero network that you would like for this transaction to take place. And then, once you tell the rest of the network, you need to pay a small fee to miners for them to actually include your transaction in the blockchain. You can think of the blockchain as just the entire list of all the transactions that have ever happened throughout the coin's entire history. And every few minutes, they'll add a new block with the most recent history to it. So Monero is the same way. Okay, so Monero is the same way, where you still have the sender and receiver, you still broadcast the transaction, and then miners include it in the next set of history of the transactions. But in this case, with Monero, I'm just going to go through the 4 ways that we work to make your transaction private. And so I'm going to go into each of these in detail, but for the sender, we use something called ring signatures in order to hide the sender in the transaction. As of January, we use ring confidential transactions to conceal the amount used in the transaction when you're sending Monero. We have many developers working on an implementation to hide the origin IP address for a transaction broadcast. That'll be done through our built-out router called Copry, which is an I2P router. I'll talk about that a lot later. And then finally, the person who receives the Monero in the transaction has their identity also concealed with stealth addresses. So you can see that throughout the whole scope of the transaction, either we have methods in place to protect privacy, or we're working on that third one right there with Copry. So just let's start off with ring signatures. So I want you to imagine the entire blockchain, and the best way to imagine this is, imagine that these are just euros, and so you have different denominations of euros. You have a 10 euro note, 20 euro note, 2 euro coin. They're just divided into different fractions. And as there you can see the different boxes, those are just different inputs of Monero, and they're just different amounts of Monero. So they're divided the same, in a similar way that you would have your the euro notes divided up, so that each of these is just a fraction. And let's say that this red one right here is one that you have. So it's as if you had 20 euros in your wallet. You have, like, let's say 10 Monero that show up in your wallet balance. So these are yours. What we need to do when we send the transaction in order for it to be private is to conceal that this red one highlighted here is the one that's actually being spent. We don't want other people to know that this is the one that's actually being spent. So how do we do that? Well, your wallet software will automatically select other inputs. And these are inputs that other people control. So just random other people that you've never met before, and you don't need your permission. Their permission. You literally just borrow their inputs. You're essentially borrowing their money, and so therefore that way you can hide which one is actually the one being used. So let me just walk you through how that works with the ring signature. So again, you start with your input, the one you do have. Your wallet will select other inputs that other people have that you don't control. And then the idea is that to an outside observer, you would make it appear as if all of these were being spent simultaneously. And there would be no easy way to determine which one is actually the one that is being spent. So in this case, I use 6 inputs, so the ring size is 6. Currently, every transaction on the network has to have at least 3 inputs, so they have to choose other inputs that are not theirs when they're sending the transaction, which means that for each transaction, all of them by mandate need to also have some information to obscure what the origin is. In September, there's a plan to increase it to at least 4 other inputs that are used. However, there are some discussions to increase that a little bit further, because obviously if you have more inputs, it means that you have more to hide with, and therefore improves your privacy and also the privacy of others. One question we constantly get is, if you're borrowing other people's money, what prevents you from spending other people's money? Because that would obviously not be a good thing. And so that's where the key image comes in. So with the key image, it is like a hash, but the input you do have, so just the red one. If you pick different blue inputs as you see there, it wouldn't change the key image. And all it does is, all those need to do are verify 2 things. 1, that it hasn't seen it before, so you're not trying to spend the money twice. And 2, that it actually is from the input you do have, so you're not trying to spend someone else's money. So previously we used all of the inputs in the transaction. So people, as an outside observer, could know how much money was being spent, like how much Monero you were sending to another user. And we didn't think this was a good idea. We wanted to also hide this. So we thought, instead of using the whole input, how about we just use a fraction of the input that only you know? So you can see here an example. I used about half of each input, but no outside observer would know how much is being used here. And the way that is done is with this fancy map called a Pedersen commitment. It's based off of confidential transactions that was made for Bitcoin but never implemented. And it's really, I have some of the math there, but it really is of 2 components that make it up. So first you have the random number that only you know, and then you also have the actual amount. So that way, by having this random number in there, this random coefficient, they are able to also hide how much is actually being sent in the transaction. But you can still prove to the rest of the network that you have the right to spend how much you're actually spending. Okay. And then, so as a result, you just sign the ring CT ring signature. So this is what you can push out to the rest of the network. It takes your input, all the other inputs, takes only a fraction of them, and it tells the rest of the nodes that I want to make this transaction, which means that you end up with an unknown amount of XMR that is actually being sent. And as an output, you also have the commitment public key, which I won't really talk about, but that is how you prove to the rest of the network that you have the authority to use the fraction that you're actually using. So a lot of people understand for an individual transaction how they take their input and hide among other people's inputs to know hide which one is the real one. But people often forget how the inputs are used across the history of the blockchain. So I have the same inputs here as before on the left. Your red one is in red, and I've just boxed here in red the history of how this input was recorded in the blockchain in some way. There are really three ways they can be recorded here. One, it's new money, so it would show up so that way we can still verify the supply. Two, if you control this input and send it to somebody, obviously it will show up in the blockchain as a record going among the other inputs that are sent. And then also, and perhaps most importantly, is that perhaps another user borrows your input to send their transaction with. So this way you could say, hey, even though all these red arrows are here for the amount of time that showed up in a transaction, it doesn't mean I actually spent it even once. It could have been spent none of these times or all of these times. There's no way for an outside observer to know, and that's why we think it's really powerful and kind of provides evidence for how a lot of people borrowing other people's inputs helps protect your privacy, how other random people still help protect your privacy. So what's kind of come under controversy as of late is how the inputs are actually selected, so the other inputs in the Monero transaction. And I just want to take a few moments to talk about this. And so as you go to the right on the little chart there, you can see that those are the more recent inputs that are selected. So when Monero first launched, it was a pure random selection of the inputs that were used. So you had the same chance of picking the oldest input as the newest input among the other ones. And that might sound like a good idea because it's hard to predict, but that's actually not very good because people are much more likely to spend Monero that they've recently received. And if that's the case, then there's much less likely of a chance that someone else would have borrowed that input if they also are likely borrowing ones that are really, really, really old. So that was a problem. And we realized that was a problem, so we have a temporary solution called the one that's under current, which is the triangular distribution. This means that there's a very, very, very high probability that at least one of the inputs that is selected is within the past 5 days. However, this is still not ideal because people, about 70–80% of the time, spend Monero the same day they receive it. So that's why we're still working on an ideal solution that would use the inputs, more recent inputs much more often in order to also have a better input selection algorithm. This is something that people in the Monero community have been working on for some time, and it's also something that outside researchers have been commenting on for a while too. So a lot of people understand why you would want to obfuscate information that's stored on the public blockchain that everyone can see. But people often forget how it actually gets there. So the process in order to actually get your transaction on the blockchain. And when you're broadcasting to the rest of the nodes that you would like it for it to be included, you're actually revealing a lot of information about yourself. So imagine this green dot on here, the origin node. Imagine that's you when you're sending the transaction. And so you're telling the rest of the nodes in the network that you would like this transaction to be included in the next block. Now the problem is that some of the nodes, and you don't know which ones, are logging the IP address that they receive these requests from. And so it's not a surefire method because you aren't connected to every node at the same time. They might get the first transaction from a different node, not the real one. But in some cases, the origin node might push the transaction directly out to a logging node. And that's not good because even though they don't know anything about the transaction itself, they can tie that transaction with good certainty to your IP address. And then they can come try knocking on your door and ask you, hey, who are you sending Monero to? We think you sent it. Please tell us what you were doing with it. Or threaten you, ask you to tell them what they're doing with it. So that's obviously not a good idea. So in order to help mitigate this issue, many developers are building on Cabri, which is an I2P router, which works with Monero. I'm guessing, can I just see a show of hands real quick? How many of you have heard of I2P before? Okay, so clearly the minority. So how many of you have heard of Tor before? Okay, so I2P is a hidden network on the internet. It's similar to Tor, except the technicals are obviously very different, but it's better. I2P is better for a peer-to-peer network, so things like torrents or what we're doing where we're syncing block data or syncing transaction information. But it's much worse for accessing normal websites like Google or Facebook. So it's just more aligned with what our goals are. And so by putting just the transaction broadcast under this I2P layer, we will have the option for you to put all block sync data through this layer. If you wanted to hide from either your government or ISP that you were using Monero in the first place, you could hide that by sending all the data through. But for most users, we're just going to put this broadcast data because that's the big privacy leak. And by doing that, instead of them getting your actual IP address, they're just going to get, as you see there, they get the actual IP address. They're just going to get this meaningless and I2P address that has no connection with either you or your actual IP address. So in this way, that an attacker wouldn't know that, who's most likely to actually be sending the transactions in the first place. They have no idea. So this is still quite a ways off from being implemented in Monero, but we currently are, I've been told at least, a few weeks away from an alpha release that has basic router functionality, so you could use it for interacting with the I2P network, but not quite with Monero yet. That's still maybe at least a year out. This is where we are, though. You can see me connecting to one of the I2P websites. It's called an Eve site. I won't get into any of that, but you can see this. We're kind of in getting closer to a functional state with that, and so we're really, really enthusiastic about this project. So finally, with stealth addresses, this is how we hide where the money is going to. So normally with Bitcoin, you would take your Bitcoin, and in the block, you would directly send it to an address. We don't want to do that because we don't want a record of money going to certain addresses. Instead, we're going to send it to something that looks like an address, but it's not actually their address. This is what we call our stealthy address system. So it looks just like an address here. So you can see that it's just a string of random numbers and letters. But it will only appear once on the blockchain, just this one time. And so an outside observer can't connect this stealth address to the actual address it's going to, but the person who's receiving the funds could use their private key to still look up which outputs are theirs. So again, not really getting into the cryptography here, but the idea is that an outside observer doesn't know where the money is going to, but as a participant in the network, if you're receiving funds, you can still search the blockchain and figure out which funds are yours. Speaking of that, we actually don't know in this transaction that all of these outputs are going to the same person. In this example, the red ones are going to the receiver, the one who's getting the Monero, and then the blue ones are actually coming right back to the sender. We previously used this a lot before Ring CT, before we could use just a fraction, in order to break up large inputs. Say you had like a 50-euro note and you only wanted to spend like 10. You obviously expect someone to give you change back. This is basically the same type of system, except you're just making change with yourself. You're sending it back, so you're sending the change back to yourself. So that's pretty cool too. So just in summary, we have an ambiguous input on the left with an unknown amount of each of the input that's being used, but you can still prove how much is being used. At least you have the right to use it. To lead to an unknown amount of Monero that's being sent, and then it's going to an unknown address. And then you have the public key that I'm ignoring again. So one thing in the Monero community that we're really passionate about is that we think that all transactions on a cryptocurrencies network should be private, not even by default, but by mandate. There should be no way to send a transaction that is not private, in our opinion. And part of this is from our own history. So a little over a year ago, we did not make it so that they were mandatory. And 2/3 of the time, people did not use any other inputs in their Ring signature. So they literally just took their input, so their bill, essentially in their pocket, and they just sent it without borrowing anybody else's. And so that was a problem for two main reasons. One, that obviously that one transaction is not as private as it could be, and if you did that accidentally, I mean, that sucks because it's recorded forever, right? So that really sucks. And two, is that if you are the only one that is borrowing other people's inputs and no one is borrowing yours, then it's less convincing to say, hey, I might not have sent this, maybe someone else borrowed it, if no one else is borrowing each other's inputs. So that's why it's important, not only for just the individual transaction, but for the whole strength of the network as a whole. You can see on the right, I'm not really going to name names, but another cryptocurrency that claims to be the most private cryptocurrency. But only the red portion are funds that are actually held privately. The green ones are just as public as Bitcoin, so you can see the history of what happens forever. And so a lot of people don't really understand that, and our concern is that someone's going to download the Jax wallet without knowing that they need to use a special type of address, and they're going to use this coin without using the privacy features, even though they think it's private, and then they're going to get screwed. And so we really think that that's why it's extremely important to have mandatory privacy across the network, so that even a new user that doesn't know what they're doing isn't going to shoot themselves in the foot. Okay, switching to a brief history of Monero real quickly. So it was launched in April 2014 by someone named Thankful for Today at Bitcoin Talk. Within the first few weeks, they realized he kind of sucked to work with, at least we're collaborating with the community. So within the first few weeks, the Monero core team forked the project away from this person and have had it ever since. The problem is that they have this new code that they didn't really know what was in it or how it worked, and so in the midst of trying to figure out how it worked, there was an attack in September 2014 where a very motivated and skilled attacker spammed the network with a large number of transactions. In this case, they were actually able to force a hard fork, which was obviously not ideal. So no one, to our knowledge, lost funds because of this, but it was really a critical turning point in Monero's history because we realized that secure is just some optional buzzword you can throw around or something you can treat lightly. It needs to be something that's really fully integrated in the mindset of what coin you're developing. So not too much seems to have happened in the chart between September 2014 and March 2016. But there was a lot of background work and research. So we have something called the Monero Research Lab, which is a group of academics, and they published multiple research papers showing how we can improve our privacy and security of the network. Beginning in late 2014 was the first paper that they published. Also, we switched to a different databasing structure, so you no longer had to have the blockchain in RAM. Things like that that just improve the reusability of Monero, and especially now when the blockchain is definitely larger. And then in March 2016, we finally made a major step to make all transactions on the network private. So they had to, by mandate, include other inputs, which was very important for us. And then in December, we took our first step forward to be user-friendly by finally releasing our first graphical user interface. Previously, we told everybody to use command line, and they didn't quite like that, even myself included. So this is really where we start to feel more comfortable with the code that we have, and we're kind of reaching out to make it easier for normal non-coders to use Monero, because we understand it's still difficult. And then finally, in January 2017, we enabled Green CT on the network, which closed the biggest privacy leak at the time. So on a network where all transactions are always private, how do you have any regulatory compliance or transparency at all? And we do this with something called the view key. And I'm not going to get into like private, public view key, keys or anything here with the cryptography, but I'm just going to explain just in general how it works. So it's really just this transparent string that you can give to someone, and it just reveals either the incoming amounts for a specific transaction or for the entire account, the history of all the money that's come in for the entire Monero account or wallet. So in that case, it can provide transparency for instances that might need transparency. You can give this to selected parties, so you can publish it on your website for the whole world to see, or you can just give it to your best friend. It's your prerogative. For charities, this is often what we kind of use as the go-to example for the view key, is that they can publish a Monero donation address with the view key, and then people can keep track of how many funds are coming in and compare that to the balance sheets to make sure there's no corruption or something going on. And then finally, with parents, they can have the view key of their children's accounts just to have some level of control. So I also want to talk today about some of the limitations that Monero has. And there are some advantages, but at this point I'd say they're mostly disadvantages, in that Monero is not based on Bitcoin's code. Most cryptocurrencies are forked from Bitcoin. Monero is very different. It's based off something, it's based off a completely different coin protocol. That means that we have no support for mobile wallets. We don't have a single one that supports us. And then we also don't have a reputable mobile wallet. So right now, you're either tied to your computer to use it, or you need to use a web wallet on your phone, and we know that that's not ideal. So we have a lot of people working on getting some official integrations ready. I know there are people working on both iOS and Android, but these take time, and I'm not sure if they will even be finished by the end of the year. Now, the previous ones were kind of, yeah, these are current limitations, but if you just have enough time, they'll be fixed. And I think that that's the case. But long term, I think the most common criticism people have of Monero are that the transactions are very, very large. And I'm just going to help illustrate how large they are. So this is a normal Bitcoin transaction at 0.3 kilobytes. Before ring CT, this is a normal Monero transaction, which is already 10 times larger at 3 kilobytes. And after we added ring CT, which was the important privacy feature I talked about earlier, this jumps to 40 times larger at 12 to 13 kilobytes. So you can see from this view that you'd be like, how, if Bitcoin is having trouble scaling, how on earth does Monero stand any chance at having any consideration for scaling solutions? And so I'm just going to address our community's response to some of these issues that we might face in the future. But I'd just like to start off by pointing out that in the short term, it's not a problem because the size of the blockchain is currently less than 14 gigabytes. So you can still run it on a normal VPS without really any issues. But it's just something that we want to look at for the long term, especially if we meet or exceed Bitcoin's current transaction volumes, because that's what people often project with when they say that Monero can't scale. So let's just look at our response to that real quickly. So first, ring CT is brand new. I don't know how we can improve it specifically, or we could have already done it, but it's by my estimation that there's a decent chance that optimizations could just reduce the sizes by about 20%. It could be 0, it could be 80, I don't know, but I think this is a reasonable amount to come closer to. Then part of my past basis for this is that when we switch to a different databasing system for a blockchain, we retroactively cut the size of the blockchain in half. So I think there are rooms just somewhere for optimizations. Normally our approach is get the privacy done at whatever cost it is to sort of the optimizations, and then work on the optimizations as a secondary measure. Second, we can prune or get rid of old non-essential parts of the blockchain that we don't really need anymore. With Bitcoin, you can get rid of everything because you know when things are spent. But with Monero, since you don't know when things are spent, because that's the point, you don't want people to know you spend your money, we can only get rid of about half of the old stuff. But that's still obviously a long way forward in terms of reducing the bloat. Another option that's on the table is called sharding. You can think of it like a torrent. You can divide the Monero blockchain into different pieces and put those different pieces on different nodes instead of each node having a full copy. That's something we're interested in, but we just want to make sure that our network has enough nodes and is thoroughly decentralized to allow for something like this. In the worst case, when absolutely nothing happens and Monero meets Bitcoin's volume and everybody loves Monero and people 2 years from now don't know how we live without Monero, even in that case, that hard drives are still pretty inexpensive, and we're pretty sure that either, especially if we have large usability, enough enthusiasts will either already have a 1 terabyte hard drive or would spend the $40 it would cost for a 1 terabyte hard drive to support the Monero network. So at that point, it might start to put strain on some VPS providers, but frankly, those don't really decentralize the network too much anyway. If Amazon is just hosting 1,000 redundant Monero nodes anyway. And then finally, we think that any long-term scaling needs to be done off-chain anyway. You can think of this as for a low-risk transaction, if you're only spending 10 euros like your friend or something, you probably don't think your friend is going to try and outpace the entire Monero mining network to reverse this like 10 euro transaction, right, or equivalent 10 euro transaction. So in that case, you can have certain advantages by using a different part, using a sidechain. You can have an instant confirmation, and you can have much smaller transaction sizes, which means you also pay much less in fees. So this is kind of what we're looking for everyone's idea of microtransactions and such. We can't really do that unless we use a sidechain. And with this sidechain, we expect, at least by our current estimations, I know a lot of the technology here is still heavily evolving because no coin has a good implementation of this. But at this point, we should be about what Bitcoin's current transaction size is now. So we can't really be more efficient than Bitcoin because we just have so much more stuff going on in the blockchain than they do, but we can get pretty close. And we think that is definitely a trade-off to take for the much needed privacy and fungibility improvements that we have. So I'm going to touch on some of the more tangible things on ongoing development that we have. I'm not going to talk about any of the back-end work or anything. But first, multi-sig. So this, when you currently want to spend Monero with a merchant, you need to give money to the merchant and hope that they send you whatever you bought and not just say, too bad, I have your funds already. So this way with multi-sig, you can throw an arbitrator in the middle, and if the merchant doesn't play nice, they can reverse the transaction. So that's something that the Monero developers are currently working on right now, and we have someone funded to work on this specific project. Second, sub-addresses and disposable addresses. Right now, if you publish your current Monero account, the address of the account, on your Facebook, Alphabet, and Ashley Madison for some reason. I mean, they're going to be linked across all three situations because you're using the same address. And so that obviously can be mitigated, that can be completely avoided by just some simple offset use on your part. But this will make it a lot easier to just maintain your offset because you can have one account and just multiple addresses for that account, so you can publish those in different situations if you want to keep your identity separate in those cases. Third, translations. The Monero community has worked very hard to get our wallet software translated into different languages, but as far as documentation, so things like how does ring CT work, or how do ring signatures work, it's pretty much only in English. We don't really have any other documentation for that. I know certain enthusiasts have tried adding some basic documentation. I know there's a group out of Russia that worked a little bit on that, but it's much less than the documentation we have in English. And so that's something that we definitely want to push forward if we want to see adoption for a much greater variety of populations. Fourth, and I hope Riccardo Spagni talks about this later today, are lightweight wallets. So currently, if you want to not download the little Monero node on your computer, you probably either need to use a remote node, which isn't ideal for performance, or you could use a web wallet, which isn't really ideal for security. So lightweight wallets help bridge the gap, providing a good middle ground between the two, so it's a decently secure system. Obviously, others are more secure, like hardware and offline cold wall storage. But it's kind of like an in-between that you can use in order to use Monero easier. And that's something that Riccardo Spagni is working on with his Mind Monero project. And then finally, website redesign. So Monero's website isn't awful, but it's not really easy for new users to find new information. So we have someone working to redesign the website to make it easier for people to use and also for translations into other languages too. So the hard fork schedule with Monero. Monero has regular hard forks. We hard fork typically twice a year. However, this year we have 3. We already had 2, one in January and one in April. And we still have one in September. That's on the 18th. That brings mandatory ring CT and increases the minimum ring size. So this is kind of like a privacy update. So you can see around that time. And then that's it for my presentation. And I hope I piqued your interest. If not, you still have 2 more presentations to go on. So our website is getmonero.org. We have a large Reddit community. And then we also have a very good technical community on Stack Exchange if you want to know more about how these individual things work. So I'll delay the questions until after the presentation because I know Riccardo wants to speak. But I really appreciate you guys coming out and taking the time to listen to me. Thank you.
Έχουμε 10 λεπτά διάλειμμα μέχρι και 4, οπότε και θα έχουμε τον head developer του Monero over Skype να μας μιλήσει και αυτός για τη δικιά του προοπτική. Έτσι, 10 λεπτά, 8 και 4 ξεκινάμε την επόμενη παρουσίαση.
So you can still buy it and make more money. Hard form if you just want it, and then you don't want to less than 10 $12.
Γιατί το διάβασα και όταν έκανα το φιλοθέτω έχουμε κουράστηκα.
But at the same time, once they have to not sure it might just die with a small.
Να αρχίσουμε να καθόμαστε σιγά σιγά για να ξεκινήσουμε την επόμενη ομιλία.
Το μικρόφωνο μου σου υπενθυμίσει. Εντάξει, εντάξει,
Ξεκινά να μιλάς. Το λίγο θα μιλάει.
Δεν το σήκωσε.
Hello, Riccardo. Can you hear us? All right, we can see you just fine. Can we test your audio a bit? We need it louder. Give me a second to look through the mics. Once again. Can you speak once again? Give me a second to
Από εδώ είναι στο maximum. Μεγάλωσε το από εδώ. Okay.
All right, let's try it once more. It sounds great. You can start wherever you want. So let me briefly introduce you to the Greek community. We don't have, I don't know if you can see them, but here's everybody so far. We just had a brief presentation with Justin that introduced some of the key elements of Monero and why it's so special. So you have the mic.
Cool. So thanks everyone for having me. Let me just start my slides here. All right, can everyone see my slides?
Yep. Yeah.
Cool. So, hello everyone. As you may know, or as you have been told, I am Riccardo Spagni. You may know me as Fluffy Pony or Fluffy Pony ZA on Twitter and Reddit. You may also know me as that guy who insults people on Twitter and he was so mean to me. Today I am going to talk about a bunch of Monero stuff, and I plan to follow that on with even more Monero stuff. I know that's surprising, but this is a Monero talk after all. So to start, I know that Justin's covered some fundamentals about Monero, but I think it's important to just go over Monero's core privacy aspects, especially in the context of cutting through the FUD, which is an excellent thing to discuss, given that Monero makes certain claims about privacy. So Monero basically takes 4 steps or does 4 things to enhance user privacy. The first thing that we want to do is we want to break something called linkability. Now, linkability is tracking where transactions are going to. In some research papers that have been published recently, they use the term linkability incorrectly to mean where transactions are coming from. But linkability in Monero's world is we want to make sure that we don't know who you're paying. And we use something called dual key stealth addressing to do that. Then there's untraceability or traceability, and that is we want to hide where transactions are coming from. And for that, we use something called ring signatures. And then we want to make Monero cryptographically valueless, and that doesn't mean it has no value, it means you can't tell the values of each transaction. And for that, we use something called ring confidential transactions. And lastly, we want to avoid passive, sort of passive surveillance. So your ISP is sniffing your connection, or naughty people are watching the Monero network. How do we hide the originating IP addresses of transactions? And we use something called card-read for that, which I'll touch on in a bit. So when it comes to being cryptographically unlinkable, this is not very complicated. That means our outputs go to this destination, which appears to be random. And in this example, we have 6 outputs in a transaction, and the 3 that are in red might be coming back to us as change, and the other 3 might be going to a single recipient, or all 6 might be going to different people. Frankly, there's no way of us telling, and so as far as anyone can see, all 6 of these outputs just have gone to different people or to different destination addresses. This is obviously very different to Bitcoin. Now, when it comes to being untraceable, this is where it gets more interesting. So we use this ring signature, and we go and select a bunch of random outputs from the blockchain, and this ring signature we can create entirely offline, so there's no concurrency needed. We don't need to have some sort of live connection to everyone and exchange data. We just need a copy of the blockchain. And we go and fetch a bunch of these outputs, and we create this ring signature, and that is an input. And then obviously our outputs are still using dual key stealth addressing. Now we use something called a key image, which is almost like you can imagine it as a hash of the real signature or the real signer. And the key image is just a thing that exists to prevent double spending. And the key image is obviously quite a sensitive thing, because if it were broken in some way, if you could somehow brute force a key image, then you would effectively be able to break the entire security model of the ring signature, and you would thus be able to deduce which of these inputs or which of the participants in the ring signature is the real one. Now, when it comes to being cryptographically valueless, instead of using an amount, we use something called a cryptographic commitment, which is like, you can imagine it as like a hash of the amount. And commitments aren't very exciting, except for the fact that you can do arithmetic with commitments. And so that gives us the ability to sign the difference between various commitments, and thus prevent something happening where, for example, you can create Monero out of thin air, which is a real attack that could happen, and that was possible against a very early naive implementation of RingCT, which thankfully never made it to production. Now, the thing with ring signatures, and particularly with selecting outputs from the blockchain, is that this part is really hard. It's like seriously hard, and it's the most likely to leak metadata. Now, another approach could be, for example, the way Zero Cash does it, which is that their inputs, or a single input, appears to spend every possible output from the blockchain. And that's obviously more powerful because you're not selecting a group of 4 or 6 or even 20 outputs. You know, it just appears to be like this massive ring signature that selects every single possible output. Now, the downside to something like Zero Cash obviously is that it takes nearly 8 gigabytes of RAM to create the zero-knowledge proof. It requires a trusted setup, although there is ZK Starks, which doesn't require a trusted setup. But still, there's all this complexity, there's implementation risk, and so on and so forth. And the reason that Monero does it differently is because we want every single transaction to be private instead of a limited subset. And that's something I'll touch on in a moment. But the important thing to understand, because this is what a recent paper discussed, or 2 recent papers discussed, this selection of outputs is like super hard. Now, back in 2014, in November 2014, the Monero Research Lab, which is a group of academics that are interested in Monero, they discovered a bunch of weaknesses in the way this output selection was done. And they published a bunch of suggestions for fixes in January 2015. Now, in January 2015, Monero was still a very young cryptocurrency. We had the entire blockchain in RAM. There was a lot of work to be done just to make Monero, just so you could actually run it on most people's computers. And so that was kind of the priority rather than fixing the output selection, although we did sort of do it in parallel. And when we had our first hard fork in 2016, we were able to deploy a proper fix. And that proper fix was blocking ring size 0 transactions, switching to a triangular distribution instead of a uniform distribution. And then more recently after that, we added a recent output cut-in, which is designed to basically say, well, you know, a lot of people spend their most recently received funds pretty quickly after receiving it. So how do we make sure that there's in your ring signature, there's a large portion, or relatively large portion of recent outputs, and that's this recent output cut-in. The thing is, it's still not enough. Now, why is it still not enough? It's still not enough because we don't actually know how users spend their money. And so in order to make it appear so uniform and so random that you get lost in the crowd and your real output isn't apparently obvious because of these weaknesses, we need to understand exactly how people are spending their money. Now that takes obviously a lot of time because we need to observe stuff on the blockchain. And this is basically an ongoing thing. I mean, if you look at Monero's users in 2014, 2015, and even the bulk of 2016, it was speculators and miners. There were very few transactions. Towards the end of 2016, when Alphabet started accepting Monero, then suddenly there was this whole world of actual users that appeared. And a whole bunch of other services started accepting Monero, and it became super exciting from a usage perspective. And it meant that all the data that we had up until the end of 2016 was largely users, because we can't model it, because it's not your user base. that you actually want to protect. Your user base that you want to protect are the current ones, which are behaving very differently. That said, the deployment of ring-CT was a game changer in that it destroyed any possible link to ring-0 transactions. If you can't create a ring-CT transaction and spend a non-ring-CT output because you're creating ring-CT outputs. So eventually it all just sort of like narrows down to, well, you kind of have to spend ring-CT outputs. Also, ring-CT makes or provides for much larger base ring sizes, which, you know, in this little example, I've only chosen myself plus 5 other outputs from the blockchain, but with ring-CT, it's not very expensive to do like 15 or 16 or 17 outputs from the blockchain. It doesn't cost much more than a normal ring-CT transaction. Still, this is an ongoing area of research, and it's an area where we're never going to stop figuring out ways to break the link, to break the trace rather, and the metadata leak in the transaction graph. So this is something that's, you know, like obviously it's nice and exciting to have tacit research in our hands that backs up the claims that the Monero Research Lab made way back in November 2014. But no amount of research is going to be a magic bullet for this. It just requires lots and lots of work. The important thing here, of course, is that this only affects that transaction graph trace, so that transaction flow. It doesn't, firstly, it doesn't provide absolute guarantees in terms of breaking the transaction graph or not breaking the transaction graph. But secondly, any weakness here doesn't affect the unlinkability of Monero. So dual key salt addresses still work. Doesn't affect card read, doesn't affect ring-CT. It only affects that transaction flow or the transaction graph of the blockchain. Now, when it comes to card read, this is quite an exciting project, and basically what it is an I2P node written in C++ instead of Java. And what this defends against is passive surveillance and civil attacks. So in this little diagram over here, I've got a node, which is my node that I'm running, and it's in green. And then I have a bunch of other nodes. And maybe there's this really bad person, the NSA, I don't know, whoever the NSA equivalent is in Greece, and they've set up a bunch of logging nodes. And now what happens is when I broadcast my transaction, invariably I hit one of these logging nodes because they have so many of them, because, you know, they're the Greek NSA and they're not money. Or maybe they're, I don't know. And so what they're able to say is, oh hey, the first time I saw this transaction, it came from this IP address. Okay, that's obviously bad, because that's my IP address, and now it's like hacked. So what Cobry does, and this is something that we haven't deployed yet because we're still working on it and it's in alpha at the moment, is we basically have a second layer running over I2P that connects nodes together. And I2P is like Tor, it's a hidden services layer on top of the internet. And it means that when I broadcast my transaction, by the time the logging node sees it, even if the logging node is the first node that I hit, it doesn't matter. Because all it's going to get is an I2P address. And the I2P address is unrelated to my real IP address. As long as we can make sure that, you know, we're not leaving metadata on both sides of the network. And so this becomes really powerful because you keep breaking the links, the possible links that somebody might have between, you know, the node that broadcasts the transaction or where the transaction came from, and so on. And so all four of these different aspects to Monero's privacy they're not complete. You know, there's ongoing work. Even something like dual key stealth addressing, which, you know, we might consider done. Nicholas Courtois, who is a cryptographer and professor in the United Kingdom, he has a bunch of really interesting and novel attacks that can weaken the strength of Monero's dual key stealth addressing. And he has a bunch of really cool ideas for improving it. So none of this stuff is ever done. Privacy is not a magical switch that you flick and go, oh yes, I use Monero, I'm now automatically private. From our perspective, we want users to be able to say, yes, I'm using Monero, I'm automatically private. But we also know that that's not possible, and that privacy is an ongoing exercise, just like security is an ongoing exercise. And that's one of the reasons why we have hard forks in Monero every 6 months, and in future, every year, whatever, when it becomes harder to do hard forks, because it lets us deploy improved privacy features or improved privacy technologies that the community can then adopt. Now, when it comes to privacy in Monero, and this sort of goes back to the reason that Monero provides stronger privacy than Bitcoin, but weaker privacy than something like Zcash, is because we want to keep the cost of privacy very low. And this allows us to make privacy mandatory. Every single transaction in Monero is private. You cannot opt out of it and create a non-private transaction. You can publish the details on the internet, but unless a bunch of people do that, like 80% of Monero's users, it's pointless. You're not like really damaging anyone's privacy except yourself. But if you have to imagine a cryptocurrency that had 100,000 users, and instead of having mandatory privacy, it had the magical cloud of privacy. And let's imagine this magical cloud of privacy is so powerful that it just automatically makes your transactions private. But only 1,000 users use it. Because A, most people are lazy, and so even if the cost of privacy is near zero, if it's not mandatory, they won't use it. And B, if the cost of privacy is slightly higher, like you need to wait for 2 seconds longer for your transaction to work, people are just not going to use it. They're going to be like, well, I can just, not have privacy and let everyone, see my transaction data, as long as my transaction takes half a second faster on my iPhone. Now, the problem with this magical cloud of privacy and its limited set of users is that you restrict the anonymity set to those 1,000 users at best. So even though your cryptocurrency has 100,000 users, the fact that only 1,000 of them are using the magical cloud of privacy means that your cryptocurrency's privacy set, your anonymity set, is tiny. It's 1,000 users. And that's at best. If you start introducing temporal analysis, where we're figuring out when someone's using a particular thing, well, then it becomes like a whole different ballgame. When it comes to evaluating privacy technology, and this is something that is not specific to Monero, this is something that I suggest that people apply when evaluating all sorts of privacy technology, including the instant messaging client you use, and so on. Ideology is really critical. Now, with Monero's ideology, it's not to say that Monero is some sort of sterling example, but I think it's important to discuss our ideology. Monero contributors know that at the very least, our code is responsible for securing people's money. This is bare minimum stuff. But we also realize that regardless of what anyone says, regardless of me telling people that Monero is not an investment, and don't buy Monero unless you have a specific reason to, people are going to put their life savings into it. And our code may be required to protect someone's life savings. But that's not all. We're also aware that our code may be required to keep an innocent person out of jail. So someone goes and does something that we don't find particularly morally reprehensible, but the government might, or some other person might, and now Monero's privacy is the thing keeping them out of jail. And more importantly, something that might happen is that our code might be the difference between someone's life or death. So it might be that they've gone and done something, and they're in an oppressive regime. They've used Monero, and now the fact that they've used Monero is basically the only thing protecting their life. They might be put to death otherwise. And these are very, very serious. And so we treat the code that we put out, we treat the stuff we do as incredibly serious, and we try not to mess around with something that might end up being the difference between someone's life or death. And quite frankly, the way I view it at least is that any privacy enhancing project that treats their work with less care is not only irresponsible, but is indistinguishable from a scam. Because they're making privacy claims, and yet they're not living up to them. Now, Monero's growth is also something that's been quite interesting and quite topical. I'm not talking about price growth, because I find price growth rather boring. But if you take a look at Monero's contributor growth, that's quite interesting. This graph shows the number of new commits per month, and you can see that we've grown pretty rapidly, and we're continuing to grow. As Monero's maintainer, I end up with a lot of work in testing and reviewing and merging pull requests, and I'm just getting more and more swamped because there really is a lot of work being done by a very, very big contributor. How big? Well, if you look at the number of new contributors per month, we're picking up at the moment on the order of 25 new contributors per month, which leads to Monero's dev team being one of the largest open source development teams in the world, which is something that we're quite proud of. When it comes to transactional growth, we also see sustained transactional growth pretty much since towards the end of 2016, and it doesn't seem to be dying down, which is great because it shows us that Monero is actually being used for stuff besides speculation. And we can couple this with Monero's community growth because we see from 2015 to 2017, the number of unique page views that the Monero subreddit had grew in just in March 2015. It grew from 3,000 to in March 2016, we're sitting at 15,000, and now March 2017 is sitting at 53,000. And that's coupled with the subreddit subscriber growth, where we're currently sitting at 10,500 subscribers. And all of this is really exciting to someone like me, who's been around since day zero, and you sort of watching the community just grow in leaps and bounds. Now, obviously, we want to make Monero useful and usable, and so the future of Monero is very interesting to us. One of the things that we introduced recently in December was the core Monero GUI. It's currently in beta 2, and we think that, given the amount of work that we put into taking it from wireframes all the way to the final product, and the amount of work we're still putting in, it really is a well-designed and very useful GUI. It is more of a power user tool. I can't imagine helping my mother to use the Monero GUI. There will be other tools for her to use, and it's not going to be this one. But regardless of that, even for newcomers, even for new users who are unfamiliar with the way Monero works, we're trying to make things as accessible, as obvious, and as intuitive as possible. Similarly, when it comes to the additional things that we're trying to build out for Monero, there's some things that we're doing which are more usability related. And then there are other things that we're trying to do, like zero MQ between components, which is basically just a communication with the mechanism that the wallet would use to communicate with the daemon and connects to the network, and that's sort of more nitty-gritty technical stuff. And then in the far future, we're looking at doing things like introducing side chains, introducing the ability to do cross-chain packet swaps, so that you can shift from one side chain to another. But none of this is possible without our contributor base. And so this is sort of the part where, I appeal to you, if you are very interested in Monero, or at least mildly interested in Monero, take a look at working with Monero. So, for example, on the development side, Monero is mostly C++. There's some C. There's a lot of Qt on the GUI side. We use a lot of Boost, and CMake is our build system. You don't need to be strong in cryptography because the crypto parts are hardly touched. There's a lot of refactoring we're doing into libraries and putting in more external libraries with the view to eventually rewriting some components in Rust. The really cool thing is that we merge anything. So if you come along and maybe you're a newcomer, you are not very strong in C++, don't worry. Monero will merge your code, and it will give you a mentorship opportunity, because in the process of reviewing your code, there are often very specific comments that help you to improve your ability as a developer. On the Monero Research Lab side, it's an open research group. There's no restriction on who can join. Nobody cares about your credentials or history. We have people who are PhD in mathematics. We have people who are PhD in computer graphics. We have people who are PH nothing, and all of those are completely fine. The nice thing about the Monero Research Lab is that it provides a platform. So if you find a break or a hole in Monero, write it up. If you want to introduce a new feature that is complicated, write it up. If you see mistakes in the Monero Research Lab papers and you enjoy correcting the mistakes of others, write it up and you get your name in the byline. We also have a bunch of non-technical projects. There are many parts of the Monero that are pretty. There's the Monero website, which is going through a sort of redo at the moment by a contributor. But it requires content, it needs more content. There are translations required that are very in the CLI. Once the new website design is done, then there'll be website translations. There's the Monero Stack Exchange, which is desperately in need of love. So if you have questions about Monero, I suggest you direct them to the Monero Stack Exchange. It's monero.stackexchange.com. Also, the Monero subreddit, which is our Monero, really needs participants and contributors and community members who are pragmatic and level-headed. We get people coming in and saying things like, why did the Monero price go up? Or when will the Monero price go up? Or why did Monero price go down? Is it dead? And we need people who are pragmatic to calm people down and to say, please stop buying Monero because, it's not a stock exchange investment thing, it's just cryptocurrency. And then we have external projects, so libraries, tools, library bindings in other languages. We're very light to that at the moment. We want more merchant systems. How do people earn Monero? We have no real OTC systems at the moment. We have no local bitcoins or ICDM trader equivalents for Monero. Blockchain visualization tool, we have very little of that. And in my Monero is busy building out open source applications, mostly JavaScript, and those require contributors as well. So that's pretty much it from my side, and I'm obviously at this point I sort of rushed through some things, and I'm happy to take questions.
Thank you very much, Riccardo. We don't have time until the next call, so but I guess we can take a couple of questions if you guys are up to it. All right, it looks like the fluff was too much for our crowd, but we'll be getting the questions, and I'm sure there's going to be a lot of feedback from Twitter and the YouTube where this talk is being streamed. So thanks a lot, Riccardo, and I'm hoping to see you live whenever you can. We're not very far away.
Thanks so much, guys. Have a good evening.
Take care. You too. Okay. Δώσουμε δύο λεπτά για να ξεκινήσουμε την επόμενη λέξη. Hello guys. Welcome to our meetup. I'm just fine. How are you doing?
Very good, very good. How many people are there?
Let me show you.
Oh, we weren't ready to talk to so many people. Two people to get out maybe, so we can feel comfortable.
Yeah, let's throw some people out. So we just finished the talk with Riccardo, and right before him we had Justin give us a rundown on all things Monero. So we have a crowd that's excited to listen and learn more about this technology. So the floor is yours, and you can start anytime you want.
Okay, let me just see if I can share my screen. Can you see our screen?
Yep. Yes, we can.
Okay. Can everybody see it?
Yeah.
Yes, it's fine.
Okay, perfect. So my name is Ronen, Kirsh. This is Spagni. We both from Boston and Berkeley. We are an organization at UC Berkeley that educate the community and do also a few consulting projects for companies in the industry. We're going to tell you a little bit about Monero, what we know. So obviously Riccardo is the dev core. It's going to be hard to compete with the stuff that he said, but we're going to try to be biased and tell you what we know about the technology and what it really is. I hope that there's a few people that are technical. We try not to be too technical, but if it is, you can also stop us and ask questions along the way. That's perfectly fine. So let's start. So we're going to talk today about Monero, whether it's really anonymous. We're going to mention maybe the new news that was recently released by Andrew Miller, the Monero link website. An easy way of really thinking about Monero, or just an overview. If you think about Bitcoin, it's really like, me sending from my home address to mail to Spagni's home address, and it's very public, everybody knows. Where Monero, it's more like a PO box. It's an anonymous box that you rent from the mail, post office, and then I send a post to a PO box to Spagni. He has a private key to it, but nobody knows who it really is. He didn't send it to my post. Nobody knows who really is. That's essentially the aspect of anonymity. So let's start. So there's two main features that Monero essentially present as the core features. One of them is unlinkability. So essentially, unlinkability discuss whether we have two transactions, whether we can trace and prove that they represent to the same person. So if Spagni and Ronen are saying transaction, can we prove that George received both of them? This is the first feature, but I'm actually going to talk about the second feature, which is called linkability. This is the core feature that the paper essentially talks about. The paper is called empirical analysis of linkability, which linkability essentially asks, okay, assuming George sent out two transactions out to Spagni and Ronen, can we prove that it came from George? This is very common in Bitcoin. As we all know, Bitcoin is not anonymous. If we send a transaction, we can trace it back. But Monero is supposed to solve that. So this is what we're talking about with the Bitcoin style. Spagni received, someone sent Spagni a message that I had a transaction, Spagni received it, and if Spagni sent it, you can go back and see that actually Spagni was the one that sent it. That's how Bitcoin works. I hope everybody kind of remember that. If not, let us know. But I hope in Greece people know what Bitcoin is.
Yes, we do.
Yeah, well, you guys need it. I mean, I personally love Greece, and I feel like there needs more adoption in Greece. So I'm happy to see you guys really pushing this forward and this initiative. I'm also going to be in Greece, by the way, in a month. So I'll come to visit you in the next meetup, that's for sure. Okay, so let's go to the Monero aspect. So in Monero, we have a few public transactions, Ronen, Spagni, and Jordan. Okay? Now, in that case, let's take Spagni as an example. Spagni decided that he wants to send a transaction out, but he doesn't want to be revealed, he wants to be anonymous. So what he does, he takes the Ronen's public key, and George's public key, and he combines them together. What it means essentially that's called mixing. Okay, so you take Spagni's public key, Ronen's public key, George's public key, and Spagni private. As you can see under transaction key, it shows what the real signature is. The mixing aspect, that's a term that you should all be aware, is essentially combining more than one public key into the ring transaction. And then when you send it out, there's going to be Spagni's private key that's signed. What it actually does is essentially saying, if I'm a third person looking at this transaction, I don't really know if the private key comes from Spagni, comes from Ronen, or comes from George. So from an external, if I look at a helicopter view, essentially there can be 3 people that send a transaction, and I don't really know who that is. So there's 33% of actually me guessing whose transaction is.
So what this process is called, the number of mixes that you include is the anonymity set. So we can compare this to 2 other currencies. This diagram is right from Miller's white paper. So he shows a diagram comparing crypto node, which is what Monero uses, comparing Bitcoin, and of course, him being advised to the Zcash project, of course, wanted to include Zcash in the paper as well. So in Bitcoin, the transaction set is always of size 1, which is public and transparent which transaction output was used as an input for a new transaction. In Monero, a crypto node which Monero uses, the anonymity set is variable and is chosen by the user. And in Zcash, which it uses all past transactions as part of the anonymity system. However, these 3 distinctions show an issue that crypto node users have to solve that's not really present in the other 2 systems. In Bitcoin, how many possible anonymity sets can you create? You can only create 1 because you use the real transaction and nothing else. There's only 1 real transaction to choose from. In Zcash, how many sets are there to choose from? There's 1 because you choose the real transaction and every other transaction has an anonymity set. So there's 1 possible anonymity set. However, in crypto node, you choose 1 real transaction and a random number of mixing transactions. And not only is there a number of mixing transactions up to the user, but also which transaction you use as a mixing. So if you want to do 2 mixes, you could use any combination of 2 transactions in your crypto. So the crypto node white paper itself does not actually discuss the methodology for choosing the anonymity set. This was a task that was left to the developers of the Monero implementation. And so the Monero capability paper and Miller's paper focuses on this question and points out some major flaws in the way that anonymity sets are currently created.
So as we mentioned, the mixing aspect that we mentioned earlier is not in the crypto node white paper, which the crypto node is essentially the protocol that Monero is based on. As you can see from this diagram, when you make a transaction with crypto nodes with Monero, you can pick which public keys do you want to use in a combination with your public key.
So, Andrew Miller, in his paper, he brings up 2 major problems with the way that mixes are selected. One is the chain reaction problem, and the second is the timing problem. Well, first start by discussing the chain reaction problem. Basically, this is the situation that we ended off with last time, where I wanted to create a new signature, and I used Ronen and George's public keys in order to obfuscate my transaction. But now what happens if I go ahead and Ronen goes ahead and creates his own transaction, but doesn't use any mixing? Essentially, so basically he decided to create essentially a Bitcoin-like transaction where he doesn't obfuscate his transaction at all. And it's with 100% certainty that he used his beat out in transaction F. Now, how does that affect? The problem is that affects my transaction as well. Because now any onlooker is seeing the 100% probability that Ronen engaged in transaction F. That output means he could not have partaken in transaction E.
So essentially, what we see is that if I'm looking from a helicopter view again, now I know for sure that out of the 3 public keys that were originally in the ring. One of them, I already know whose it is, and I know it's Ronen. So in order to, so now I've already left 2 other public keys that I have to guess which one is the real one and which one is the fake one. Assuming that Sunny is the real one and George is the fake one in that case.
And now if George went ahead and created its own transaction with no mixins, it would basically get rid of his likelihood of my transaction as well, giving me 100% chance of having made that transaction.
And then you can think about it this way. So if Sunny wants to send out a transaction, he's not going to choose an output that's already being spent. So if he knows that Ronen already spent his output or his coin or his money, for example, he's not going to choose Ronen to be online with his ring. He's going to choose people who haven't spent their transaction. But the problem is that later on, after Sunny already used Ronen in the ring, Ronen can then actually spend the transaction like with a Bitcoin style transaction. Therefore, it actually hurts Sunny, but although Sunny didn't plan that this is going to be the case.
And the problem is that for a good period of time, almost 65% of all Monero transactions were not using any mixes, because the most popular desktop client had a default setting of no mixes. So this actually compromised the privacy of the entire network significantly. So now the question is, does this mean that I cannot use anyone else's transaction? There's a chance that they might not be using mixins? Well, let's see what happens if they are using mixins. So let's say Ronen went ahead and created his own transaction and used the 2 mixins as well. Now there's a 33% chance that Ronen had created this new transaction, but there's also a 33% chance that Ronen was a paper and equal in my transaction. So the thing is that if everyone agrees to use mixins, it just introduces so many variables and complications into the system that it's essentially impossible for anyone to tell. And so if everyone's doing a decent number of mixins, the number of paths grow rapidly, the more mixins that are happening. There's a very high number of possible ways that transactions can get done. So that was essentially the basis of the chain reaction problem. Now we'll go ahead and discuss the second problem that Andrew Miller brings up. It's the timing problem. Essentially, what we see is that naturally, the users that make more transactions will tend to make transactions at a faster rate. So it's almost natural that for most transactions, the real inputs tend to be the output from a relatively recent transaction. This is because people who are using the network more often tend to spend money quickly after they receive it. And so these graphs show some empirical evidence from Miller's writing. So if we look at the chart on the left, chart A, it shows the age distribution of input transactions. And so on the bottom x-axis, we have the age of a transaction input before it was spent.
So essentially, the age distribution is that assuming I send Sunny a transaction today, how long it takes until he's going to spend the money that I send him, essentially. That's the age distribution.
So now if we look at chart B, this is actually using the previous method of the chain reaction problem. There's some transactions that we can provably say are false inputs, right? So what this graph actually does, chart B, middle, is graphs only the ones that have been provably shown to be false. And as you can see, these tend to be on the tail end of the distribution. And then in chart C, if we remove all the provably false ones from the overall distribution, we're left with a distribution that tends to be more of the real transactions. And as you can see, most of these transactions are skewed towards the younger side of the age distribution. And essentially the whole point of this is just to give empirical evidence that in fact, real transactions tend to be very young. And Miller goes on in his white paper to prove that in almost 80% of all the transactions, the most recent of the 5 paper transactions tends to be the real one.
Are there any questions on this before we continue?
Yeah, I have one real quick.
Just a second.
I hope we have an answer.
So you said that 80% were from the most recent. That includes zero mixing, correct?
Well, can you repeat that?
So you said that 80% are from, or that you can trace the most recent one that was spent. Does that include zero mixing transactions?
Well, I don't think so. I'm pretty sure that the 80% is from all transactions that include one or more mixes.
And also, we're gonna talk about the timeline. There's really a timeline from when, so before, we're gonna talk about it in a second, but you're gonna see that it really depends on when those transactions were made. So after January 2017, things have changed a lot. And then also throughout 2016, there's a few outbreaks that kind of changed this probability of actually finding the transactions. We're going to talk about this in a second.
All right, thanks, guys. You can carry on.
Sure. So this is basically a rough timeline of some solutions. So the thing is, these problems that Andrew Miller has presented are not new problems. They've actually been known in the Monero community for a couple of years now. What Andrew Miller really did was show the severity of the problem by doing an in-depth data analysis. And so yes, the timeline problem was known, but what was unknown was that it compromised almost 80% of the transactions. And so over the course of the past few years, Monero has actually been pushing updates to solve some of these problems. And these are some of the major solutions which I will go into. So let's start by solving the mixing problem. So in version 0, desktop clients had a default instance set to 0, which means that a high number of all Monero transactions were not using mixins. And then in version 0.8, it implemented mandatory all of these transactions like mandatory two-based requirement. And so what we can see when we graph on the figure 5 is once the number of transactions that we're not using mixins drop after this update, we see that the number of that's starting to see that the blue line. It went from around 70% down to 0%. The number of compromised transactions dropped from 95% to almost 20%. That's the gray line. And the reason it only went to 20%, though, instead of 0%, is because new transactions still be referencing older transactions that had zero mixins. And so how do we get to solving this is version 0.1, in a new view called ring TG. It was designed for the purpose of hiding the denomination amounts for points, but it had a little bit of a side effect that all RIG-CT transactions can only use other RIG-CT transactions as inputs. And because RIG-CT was implemented after this visit, and all the new transactions, all the new transactions are RIG-CT, are only reference transactions that are also RIG-CT, which have at least 2 mixins. So all the new transactions essentially become suffer from chain reaction as there. And this has essentially solved the problem. So any transaction that you created after January 5th of 2017 is affected by this solution.
So if you have any Monero coins, you should just trade them for the new ones, and you're probably going to be fine.
Now, what about the timing problem? So in version 0, it put a uniform distribution that there was a chance of any age being selected, right? And this is a huge problem where, like I said, under the uniform was 95% a transaction was from the nearest transaction.
So essentially, uniform distribution mixing is saying that every transaction has the same likelihood of being picked. So if Sunny send me a transaction back in version 0, he can choose any of the old transactions throughout the history, which we know that in version 0, most of them had 0 mixing. So it's much easier to trace back whose Sunny transaction is, which one is the real one versus the fake one. It gave a priority to an older transaction to be included in the rings.
So the Monero developers recognized that this was a problem. So what they did was they implemented a new strategy called triangular mixing strategy. And what essentially this does is it creates a system that favors new transaction equals as mixins. And so it's called the triangular strategy because it's represented by the graph on top. It has a rough triangular shape where newer transactions, this time the graph is actually reversed. Things on Parliament right represent newer transactions. These are more likely to be chosen. However, what Andrew Miller did was, with this empirical evidence, this is the graph through this side, just horizontally match the top ones, is that he showed that yes, the triangular mixing strategy helped, but it is still not nearly as skewed as the reality of the situation. And essentially, the triangular mixing strategy underestimates students of age distributions. So there has been work to further fix the triangular distribution problem, where there's new mixing selection policy in version 0.1.1, and in this, new strategy at least 25% of mixins have to be the most callable mixins, which is transactions that occurred in the last 5 days. This should hopefully help solve the problem a little bit, but this feature has been developed but hasn't been activated yet, so it's yet to be seen how this fares in practice. Andrew, however, comes up with this one solution to the timing problem. He basically says that the triangular distribution is a lack of knowledge distribution. It's a number of developers trying to predict what the distribution of the map is going to look like and create a model that matches it. But what he says now is, hey, I've done a lot of data analysis and I figured out the real distribution of real Monero data from past few years of Monero transactions. Now that we have a real distribution that matches reality, we can use some level of data-driven design and basically create a distribution that matches the one that we see in reality. And he also suggests that beyond just using a base distribution, you can also, in the long run, you can implement new software components that every individual, let's say every 2 weeks, it recreates the distribution of the past 2 weeks of data and just its sampling strategy based on the real data of the last few weeks. And so this will make it adaptive to changes in the method. So the question now is Monero anonymous? And we're going to say the resounding yes, because essentially the crypto protocol is and has always been secure. And the problem that Andrew is really in message selection strategy. Of the 2 problems he mentions, the chain reaction problem has effectively been solved. And the timing problem is in the process of being solved by Monero developers. And there's been a lot of criticism and politics, I'd say, about, Andrew Miller's on the board of Zcash, is he trying to hurt Monero? But as you can see, we really believe that he was actually doing something to help the overall industry. Because not only did he bring up problems, he presented legitimate and valid solutions to these. And so if we actually take Andrew Miller's road and try to implement more adaptive solutions, we can increase the anonymity of Monero even farther. So yes, we believe that Monero still remains extremely anonymous and is a valid contender to the valid privacy policies.
So yeah, thank you so much for letting us speak.
Thank you very much, guys.
I have a lot of knowledge we'll be happy to help. Actually, we're supposed to give away Bitcoin, but it didn't happen today. We have our wallets with us and we cannot send it over. I'll bring it when I get to Greece.
Absolutely. We'll be following up with some practical demonstrations here and sharing Bitcoins with the crowd here. So we've got that covered for you. Thanks a lot again for a very interesting presentation and hoping to see you here anytime you can make it. Thanks a lot, guys.
If you have any questions,
Do we have any questions? One question back there. Give me a second.
Okay, so hello first. Okay, my question is that the analysis that was presented in the paper was of a statistical nature. But if I want to protect my own transactions, how do how does this relate to my own transactions? I want to make sure that my transactions are not traceable. So do these statistical results have an effect on my level of privacy when I do transactions? I mean, what does it actually mean for somebody to actually track an amount moving through different transactions?
Yeah, sure. So essentially, we want to make sure your personal transactions are as anonymous as possible. The number one thing you should be doing is just make sure you're using the latest version of the client and protocol. You want to make sure you're not using the older desktop client that has 0 leases. You want to make sure you're using RIGS GTs, which, like you said, now you can only use transactions that don't do mixes, that do mixes. So if you do that, that will actually reduce your increase in anonymity by a significant percentage. And if the client, if by default uses the default client that Monero publishes uses the granular distribution, but there are opportunities for anyone to create newer clients. I'm not quite sure if there are other alternative clients out there that use different distribution strategy. But so yeah, if you want to create your own distribution strategy, that if that's a possibility. But really, I think the basic thing is just make sure you're constantly updating the latest software and the security cases.
or you can use Zcash maybe.
Yeah, actually, the question I was asking wasn't about more like what I can actually do to make my transactions more private, but in the sense that, okay, I go to the blockchain and I make a transaction. Does this paper help me track this transaction through the blockchain as it flows forward? That is the question.
Yeah, so another thing that you could do if you want to maximize the entity is in the Monero client, you can choose the number of mixes you do. And in the latest version, the default is actually 4, but you can set it to up to 12. And if you increase the uses, Miller does an analysis of this in his paper, where if you increase the number of mixes, you can increase the anonymity significantly, because now you're increasing your possible deniability. But on the other hand, you have to weigh that with the fact that if you increase the number of instances, you're using more public keys in your signature, which will increase the size of your signature, which will mean your transaction will be larger and you'll have to pay higher transaction fees. But this is sort of a cost benefit that you have to do transaction fee versus desired end pay.
Yeah. Thank you very much.
Essentially, the Monero is like very much like other currencies. It's much like a network effect. So if more people are using it, more people are mixing, it creates better anonymity. If less people are using it, less people are mixing, there is like much less anonymity. So if you are, as I said, if you are planning on using it for, I don't know what you want to use it for, but you try to stay anonymous. Try to have as many meetings as possible. I think the cost benefit actually makes sense if you don't want to be traced back. But again, we haven't done our own research on these topics. So, things might happen and things might come up that we're not aware of yet. So just keep that in mind. Also, Zcash, for those who are familiar with, they have the privacy feature, but most of them are not being, unless you choose the feature, it's not private. So just also have something to keep in mind for future. Thank you so much for having us.
Another quick question. Can you tell us more about blockchain at Berkeley? What type of organization you are? Who is your membership? Who is your audience and so on?
Right here. So Blockchain at Berkeley, our mission is essentially to educate and bring awareness to the industry. We have 3 different departments that we're doing. One of them is the R&D, which Spagni is in charge of. It's more working professors, PhD students, master students that work on research and protocol level consensus, different papers that actually push it forward. We have the education where we teach a 2-unit class at UC Berkeley, towards your degree. It's a blockchain and cryptocurrency. You guys can watch it on our website. Look at blockchain.berkeley.edu/decal, DECAL. This is our class. It's open source. It's mainly an abstract of how Bitcoin works, how Ethereum works, how the blockchain works. Really the basics, technical aspects that people need to know to really be knowledgeable in the space. And then besides that, we have another two workshops that we're teaching. One for business people that want to learn how to consult in the space, and another one is for Ethereum development. This semester, next semester, we're going to work with IBM and create a high-closure workshop. And then our third department is the consulting. When we work with companies like Airbus, like Mobile, we actually go and build products for them. We build pilots. So this semester, we work with Airbus. We created a small function modularity that people can, the engineers can use without actually understand how the blockchain works. So I think it's going to be open source. So once we open source it, people can play around with it and see what we did. And then now we're working on top of that for more education of executive level. So we go to companies like consulting companies as well as corporate government companies. We teach the education to the executive level. We kind of expose it to the industry, expose the technology, what it can do for them, how they can use it for future benefits, and how it's going to take a lot of business.
That sounds great, guys. So personally, I didn't know about you or this initiative so far. So on behalf of the university, I will be contacting you to see explore what further collaboration space exists. So until then, I want to thank you very much for taking the time and giving us a rundown on a very important topic, which I'm sure is going to be more important as time passes and people become aware of the importance of privacy, especially in the blockchain space. So we're hoping to see you live whenever you manage to get down here, or we'll be happy to host you in another meetup further down the road. Okay, guys, thanks very much. Bye bye.